SC 3D, Dynamics of Rigid Bodies, and I will discuss the relative motion and the last static acceleration. The wheel of a radius r rolls to the left without slipping, and at the instant considered, the center O has a velocity VO and an acceleration AO to the left. Determine the acceleration of point A and C to the wheel on the wheel for the instance considered. So first, in this problem, we need to get the angular velocity and the angular acceleration. So angular velocity is equals to VO over R, and angular acceleration is equals to AO over R. So next is we need to get the acceleration of point A is equals to AO plus A of A over O, or equals din siya sa may AO plus relative acceleration of A of O normal, A of O normal plus relative acceleration A of O tangential. So A, relative acceleration of A of O normal is equal siya sa may R W squared. So equals din siya sa may R VO over R squared. Dito nang galing yan, dito. So yung relative acceleration of A of O tangential is equal siya sa may R angular acceleration, or equal siya sa may R times AO over R. So dito siya nanggaling. So for acceleration for point A is we need to use the square root of relative acceleration of A of O normal squared plus the relative acceleration of A of O ng tangential squared. So para makuha natin tong A of A is kailangan natin mag-drawing para mas lalo natin makuha yung variables ng itong dalawa na to. So first is yung A of O and A of A ito yung relative acceleration ng A of O tangential and ito yung relative acceleration of A of O normal. So ito yung angle. So, ang una natin kukuhanin is yung relative acceleration of A of O normal. So, ito yun. So, para makuha natin yung una is, kapag ka nag-drawing tayo dito, ito yung angle. So, makukuha natin to dito, may A of O, cosine. So, magiging ganito siya. So, kapag kinuha natin to, sa dito angle, so, makukuha natin yung cosine. So, A of O, cosine theta, plus, relative acceleration of A of O, normal. Susunod naman is kukunin naman natin itong relative acceleration A of O ng tangential. So, makukuha naman natin siya ng sine. So, A of O sine theta plus A of A relative acceleration of tangential. So, nakuha na natin yung dalawa na to. So, isa-substitute lang natin siya dito. A A of A at point A is equals to square root of A of O cosine theta plus relative acceleration normal of A of O squared plus A of O sine theta plus relative acceleration tangential squared. So, ito yung first answer natin. And the second answer is A of O, acceleration at point A is equals to square root of R relative acceleration times cosine theta plus itong relative acceleration at normal A of O is equal sa may RW squared. So, squared natin siya. Then, plus R. So, equal din to dito. Relative acceleration of sine theta plus RO 80 squared. So, this is the answer kung gagamitin natin yung radius nito. So, ito yung answer sa question natin, the relative motion acceleration. And lastly, the point C on the wheel for the instant considered. So, point AC is equals to AO plus acceleration of C over O. This is the formula that we obtained in the instantaneous zero velocity. So, acceleration of C of O normal is equals to RW squared, and the acceleration of C of O tangential is equals siya sa R times the angular acceleration. So, therefore, AC at point AC is equals to RW squared. So, this is the answer for the point C on the wheel for the instant considered.